Hello everyone and welcome back to my channel. Today we are going to discuss the chapter 2 of the Geography NCERT Class 6, and the chapter is about the globe and important latitudes and longitudes. So let us start the chapter with the globe. So you might have seen a model like Earth in your classrooms when you would have been in your school time. So this model or this replication or replica is a true model or true replication of the Earth, and it is in miniature form, that is, it's very small. So it is exactly like our Earth is. Okay, so you know that Earth, it rotates from west to east, okay? And it does not rotate on a vertical axis. No, it rotates on an axis which is inclined at an angle. And this angle of inclination, what is the value of this angle of inclination? It is 23.5 degree. So if I draw a vertical like this, vertical से 23.5 degree जो है हमारी earth tilted है. And this is the same way which is represented in the globe. Okay, so जैसे हमारी अर्थ है वैसे ही ग्लोब को एकदम करेक्ट और ट्रू फॉर्म देके बनाया है. So that's why you will see that all the countries, all the continents, they are of correct size. As compared to if you compare it with a map, मैप में हम जनरली क्या करते हैं, मैप में हम ग्लोब को स्प्रेड आउट कर देते हैं एक पेपर की फॉर्म में, राइट. सो व्हाट हैपेंस इज, जो हमारी ऊपर कंट्रीज आ रही हैं वो हमें थोड़ा स्प्रेड आउट दिखेंगी, राइट. तो वो एक्चुअल साइज नहीं बताते. सो मैप्स जो हैं वो एक्चुअल साइज ऑफ कंट्रीज नहीं बताते या कॉन्टिनेंट्स नहीं बताते, बट द ग्लोब, इट टेल्स अस the correct size of the countries and the continents and the oceans. Okay, so on the globe you can see here countries, continents and oceans, they are shown in their correct size. And the globe is not fixed, it moves just in the way that the earth moves. So it can be rotated along, you can see this needle over here, so it can be rotated along this needle, and this needle basically represents the imaginary axis over here which is tilted along which the earth is moving. So it is obviously not an actual axis, it's an imaginary axis, and it is tilted at 23.5 degrees. Okay, now it will be very difficult to locate a point or a city on such a sphere. So how do we find location of a city on this globe? So for that we need certain reference lines. Okay, so these reference lines are what are we going to discuss today, and these are known as latitudes and longitudes. Okay, apart from that, you can see that we know the earth, it is not a complete sphere, right. It is slightly flattened at the north and south poles and has a bulge in the middle. So it's like this, it's slightly flattened at the poles and it has a slight bulge in the center or the middle, right. And this shape of the earth, we discussed it in the first chapter, is known as the geoid. And also the 2 points, the top and the bottom point here, they are known as the poles. So this one is the north pole and this one here is the south pole. I hope that's clear. Now let's move forward. Now let us talk about the first set of lines which are known as parallels or latitudes. So you can see these circles. A north pole, it is surrounded by a circle, and then again one circle is here 60 degree north it says, and then another circle. So if I see one side of the globe, this circle will appear to me as a line, right. And it would appear to me that these lines are parallel. Okay, so remember latitudes, these lines, they are called as the latitudes, and these lines are imaginary lines that we have drawn to locate the position of a city, say, right. And for that मैंने पहले बताया that you need some reference line. So the first reference lines that we are talking about here are the latitudes, or what we call as the parallels. So नाम से ही clear हो रहा है, parallel lines होंगी. So that means, what do we mean by parallel lines? We have done in maths, right? Parallel lines are those lines which have the same distance in between them and they never intersect. So even up to infinity, they will never intersect or cross each other. They will have the same distance between them. And if you see the figure over here, you can clearly see यहाँ पे जो lines हैं, they are parallel to each other. That means they have the same distance between them. So एक हमारे पास एक लाइन ऐसी है, इमेजिनरी लाइन, जो हमारी अर्थ को दो पार्ट्स में डिवाइड करेगी, जो कि सेंटर में होगी. Now this imaginary line which is in the center, okay, it is known as the equator. And this divides the globe into two equal parts. Okay, so two equal parts. Again हम directions के हिसाब से चलेंगे. So what are the four directions? We have north, we have south, then we have west and we have east. So ये जो latitudes हैं, right, ये north और south latitudes हैं. So you can clearly see यहाँ पे लिखा हुआ है north pole, then 80 degree north, then 60 degree north, और यहाँ नीचे लिखा हुआ है 20 degree south. That means we are dealing with north south directions. तो इक्वेटर जो है वो डिवाइड करेगा अर्थ को दो हेमिस्फीयर्स में. Okay, the northern part over here will be known as the northern hemisphere and the southern part over here will be known as the southern hemisphere. And northern hemisphere और southern hemisphere दोनों obviously equal होंगे. It's because इक्वेटर जो है वो हाफ में डिवाइड कर रहा है ग्लोब को. So what is equator? Again, equator is an imaginary circular line, very important, right? And it's an important reference point to locate the places on the earth. Again, हम क्यों बना रहे हैं ये lines? हम अपनी सहूलियत के लिए बना रहे हैं because we want to know the location of a particular place on earth. और ये जो lines हैं वो actually में lines नहीं हैं, ये जो lines हैं वो actually में parallel circles हैं. Okay, so these are circular lines. तो अगर आप globe के ये because we see this figure in a 2D, but अगर आप globe को देखोगे तो वो पूरा गोल घूमेगी line, right? And you can see it here, 80 degree north वाली line, ये पूरा एक circle बन रहा है. So these are circular lines and they are drawn from equator up to both the poles, that is north pole and the south poles. Again हम इनको measure करते हैं degrees में, okay, angles में. And equator जो है उसको, क्योंकि वो center में है, so we have given it the designation 0 degrees. So equator is the 0 degree latitude. इसके ऊपर जाएंगे तो latitudes के साथ north आएगा, इसके नीचे आएंगे तो latitudes के साथ south, S का symbol हम लगाएंगे. Okay, now we know अगर हम इसको sphere को 2D में देखें तो ये एक circle है, right? Sorry about that circle. Okay, yeah, now it looks more like a circle. Okay, so circle को अगर हम 4 हिस्सों में divide करते हैं तो हमें पता है यहाँ पे अगर हम यहाँ से start कर रहे हैं और ये 0 डिग्री है तो यहाँ पे 90 डिग्री होता है. क्यों? क्योंकि ये 1/4 पार्ट है टोटल 360 डिग्री एंगल का. तो अगर ये टोटल एंगल 360 डिग्री है और हम सर्कल को 4 पार्ट्स में डिवाइड कर रहे हैं तो जो पहला हिस्सा होगा फर्स्ट क्वार्टर, it would be 1/4 of 360 degrees. So 1/4 multiply by 360 degrees and that would be 90 degrees. So clearly जो top होगा वो 90 डिग्री होगा. Similarly यहाँ पे जो bottom होगा उसको भी हमने 90 डिग्री ही बोला है. The only difference is this one is 90 degree north and this one is 90 degree south. So 90 degree north वाला north pole हो गया, 90 degree south वाला south pole हो गया. Okay, similarly जितनी भी latitudes होंगी इक्वेटर के ऊपर उनको हम नॉर्थ latitudes भी बोल सकते हैं और जितनी भी latitudes होंगी इक्वेटर के नीचे उनको हम साउथ latitudes या साउथ पैरेलल्स भी बोल सकते हैं. Now let's move forward. So ये मैंने already बता दिया that value of each latitude it is followed by the symbol N और S. तो यहाँ एक example दी है, ऐसी बहुत सारी examples जो हैं एग्ज़ाम में पूछी जा सकती हैं. Here the example is given Chandrapur in Maharashtra, India, and another city is Belo Horizonte in Brazil, which is in South America. तो हमें पता है अगर आपने देखा हो मैप, राइट, इंडिया जो है हमारा ये इक्वेटर है अगर 0 डिग्री तो इंडिया जो है इक्वेटर से ऊपर आता है, राइट. एंड अगर हम साउथ अमेरिका की बात करते हैं तो साउथ अमेरिका का कुछ हिस्सा जो है वो इक्वेटर से पास करता है, बाकी जो है इक्वेटर के यू कैन से नीचे आता है। सो दैट मीन्स इंडिया नॉर्थ में होगा, साउथ अमेरिका का काफ़ी सारा पार्ट जो होगा वो साउथ में होगा, पूरा नहीं, कुछ पार्ट जो होगा वो नॉर्थ में भी होगा। सो यहाँ पे जो सिटीज़ की बात करी गई है, चंद्रपुर इन महाराष्ट्र इंडिया, सो इंडिया वुड ऑब्वियसली लाई इन द नॉर्थ जोन, सो दिस वुड बी अ नॉर्थ लैटिट्यूड। वेयर एज इफ आई टॉक अबाउट this city Belo Horizonte in Brazil, South America, this is actually located in the south, but both of them they are located at the latitude of 20 degrees. So ये मैंने बताया like इक्वेटर जो है वो 0 डिग्री से स्टार्ट होगा, ठीक है, नॉर्थ में जाएंगे तो अगेन 20 डिग्री, 40 डिग्री, 60 डिग्री, 80 डिग्री, एंड सिमिलरली साउथ में भी हम सेम पैटर्न ही फॉलो करेंगे, बस the only difference would be that instead of writing n symbol for north we will be writing s symbol for south. तो यहाँ पे होगा 20 डिग्री साउथ, 40 डिग्री साउथ, 60 डिग्री साउथ एंड सो ऑन, राइट, सिमिलरली 90 डिग्री साउथ। तो यहाँ पे ये जो दोनों सिटीज़ हैं they both lie at the 20 degree latitude, but what is the difference? Chandrapur in Maharashtra, because India lies in the northern hemisphere, so Chandrapur in Maharashtra lies 20 degree north, whereas if we talk about the city Belo Horizonte in Brazil, it lies 20 degrees south, so below the equator. Okay, apart from that, if you see in this figure 2.2 जहाँ पे latitudes show करी हुई हैं, so you will see as we move away from the equator, the size of the parallels of latitude decreases. So you will see these circles are becoming smaller and smaller, and ultimately the north point, the north pole, it is a single circular point, right? And the size of the circles, it is decreasing as we go from equator towards the north pole or as we go from equator towards the south pole. तो इसका मतलब ये है that the size of the parallel of latitudes of all the latitudes is different. ठीक है, उनका साइज सेम नहीं है, जैसे जैसे हम इक्वेटर से पोल्स की तरफ जाते हैं उनका जो साइज है वो कम तो होता जाता है, तो जो सर्कल्स हैं वो छोटे होते जाते हैं, एंड अल्टीमेटली नॉर्थ एंड साउथ पोल वो बहुत छोटे होते हैं, स्मॉल सर्कल्स की फॉर्म में। Okay, now there was this interesting fact in the NCERT book that by measuring the angle of the pole star from your place you can know the latitude of your place. तो last time हमने pole star के बारे में पढ़ा था that जो हमारी constellation है सप्तऋषि, उसके जो पॉइंटर स्टार्स हैं अगर हम उनसे स्ट्रेट डायरेक्शन में देखते हैं देन वी कैन फाइंड द पोल स्टार. नाउ दिस वन सेज दैट if we measure the angle of the pole star we can know the latitude of our place. तो बेसिकली वो कैसे फिगर आउट करते हैं हम, all we have to do is estimate the angle between this pole star and the horizon. तो हमें horizon के with respect to जो pole star है, अगर ये हमारी horizon है जो हमें दूर से दिख रही है, उसके with respect to पोल स्टार अगर मेरा यहाँ है तो मुझे एस्टिमेट या गेस मारना होगा कि कितना एंगल ये होराइजन के साथ बना रहा है, ये एंगल। अब हमें पता है ये इस डायरेक्शन में है तो इट विल बी एन एक्यूट एंगल, और समवेयर आप थोड़ा अंदाज़ा लगा सकते हो कि 45 पे है या उससे थोड़ा ज़्यादा है या 90 के पास आसपास आ रहा है, राइट। सो इन दैट वे यू कैन नो कि आप कौन से लैटिट्यूड पे हो। ओके, लेट अस मूव फॉरवर्ड। नाउ हमने पढ़ लिया लैटिट्यूड्स क्या होती हैं, राइट, पैरेलल लाइंस और सर्कल्स, right, and they are not equal in size. Now what are some of the important parallels or latitudes or parallels of latitudes? तो एक तो हमने equator किया which is 0 degrees and of course it does not have a north or south, and then we did the north pole 90 degree north and the south pole 90 degree south. Apart from these three important lines or parallels, we have 4 other important parallels of latitudes, और ये सेम डिग्रीज पे होंगी। तो अगर हम 0 डिग्री से देख रहे हैं इक्वेटर से तो पहले लेट अस सी द डिग्रीज। पहली वाली आएगी 23.5 डिग्री पे, देन द सेकेंड वन वुड बी 66.5 डिग्री, ठीक है, एंड लास्ट हमें पता ही है 90 डिग्री। एंड सेम पैटर्न वो साउथ में फॉलो होगा, बस नॉर्थ की जगह साउथ लिख देंगे हम। तो 0 से 23.5 डिग्री साउथ, देन 66.5 डिग्री साउथ, एंड देन साउथ पोल हमें पता ही है 90 डिग्री साउथ. सो यू कैन सी दीज आर द important latitudes. So 23.5 degree north का जो नाम है that is Tropic of Cancer. Okay, and it is in the northern hemisphere obviously because we can see the N here, and जो 23.5 degree south है उसको हम बोलते हैं Tropic of Capricorn, and it is in the southern hemisphere. So this over here, this is known as the Tropic of Capricorn. एंड जो नॉर्थ में है उसका नाम है ट्रॉपिक ऑफ कैंसर. एंड देन वी हैव द आर्कटिक सर्कल विच लाइज एट 66.5 डिग्री नॉर्थ. सो जो ऊपर वाला है उसको हम बोलते हैं आर्कटिक सर्कल 66.5 डिग्री नॉर्थ पे, और जो नीचे वाला है इसको हम बोलते हैं एंटार्क्टिक सर्कल विच इज एट 66.5 डिग्री साउथ, विच इज द लास्ट इम्पॉर्टेंट लैटिट्यूड विच इज एंटार्क्टिक सर्कल हियर 66.5 डिग्री साउथ ऑफ इक्वेटर. So I hope that's clear. Let's move forward. Next है heat zones of the earth. अब हमें पता है sun जो है वो किसी भी place पे, it's not important that it is right above our heads, right? It's exactly overhead. It is not necessary. तो उसके लिए एक ये experiment है. If you would see here, हमने एक cardboard लिया, ठीक है, and then we took a torch and we turned on the torch. Okay, one time, the first time हमने क्या किया, टॉर्च को बिल्कुल सीधा रखा. So we are seeing that the torch light is falling on a straight surface, and this circle that is formed on the cardboard, it's very bright, okay, full of all the energy of the torch because it's directly in front of it and it covers a small area. तो ये एक छोटा एरिया कवर करेगा और काफ़ी ब्राइट होगा. Whereas अब हम दूसरी बार क्या करेंगे, we will tilt the cardboard. So in that case you will see even if the torch is in the same position, right? ये vertically है, हमने cardboard को tilt कर दिया है. तो ये similar है जैसे हमारी जो earth है वो vertical नहीं है, it is tilted on an axis. तो ये reason है. sun अपनी जगह fixed है. So this torch is basically the sun. ठीक है, sun अपनी जगह fixed है. अब ये जो cardboard है उसकी direction change होने की वजह से क्या हो रहा है कि हमें जो लाइट है वो चेंज हो रही है. अब ये जो सेकंड वाला केस है उसमें इसने ज़्यादा एरिया कवर करा है, बिगर सर्कल है यहाँ पे, बट इंटेंसिटी ऑब्वियसली थोड़ी कम हो जाएगी. ये वाले एरिया को थोड़ी ज़्यादा लाइट मिल रही है, ये वाले एरिया को थोड़ी कम लाइट मिल रही है. ओके, सो दिस एक्सपेरिमेंट इज़ सिमिलर टू व्हाट हैपन्स ऑन द अर्थ. ओके, और उस हिसाब से कि कौन से जोन को कितनी हीट मिलती है सन की, उस हिसाब से हमने अर्थ को हीट जोन्स में डिवाइड कर दिया है. ओके, सो ऑब्वियसली जहाँ पे सन एग्जैक्टली ऊपर होगा हमारे, वहाँ पे हीट ज़्यादा होगी बिकॉज सारी एनर्जी स्मॉल एरिया के ऊपर कॉन्सेंट्रेटेड है, राइट, एंड इट विल हैव द मैक्सिमम हीट. और जो एरिया बहुत दूर होगा सन से, वहाँ पे स्लैंटिंग रेज जाएंगी, तो ऑब्वियसली वहाँ ठंड ज़्यादा होगी क्योंकि सन की एनर्जी ही वहाँ कम पहुँच रही है बिकॉज द रेज आर स्लैंटिंग, राइट. सो ऑन दैट बेसिस वी हैव डिवाइडेड द अर्थ इनटू सम हीट जोन्स. व्हाट आर दोज जोन्स? टॉरिड जोन, देन वी हैव द टेम्परेट जोन्स, एंड देन फाइनली वी हैव द फ्रिजिड जोन्स. अब इनके साथ भी सेम कहानी है, नॉर्थ में भी होंगे और साउथ में भी होंगे. दैट मीन्स इक्वेटर के नॉर्थ और इक्वेटर के साउथ. सो टॉरिड जोन्स की अगर हम बात करें, देन इन द टॉरिड जोन्स द मिड डे सन इट इज़ एग्जैक्टली ओवरहेड एटलीस्ट वंस अ ईयर ऑन ऑल द लैटिट्यूड्स बिटवीन ट्रॉपिक ऑफ कैंसर एंड ट्रॉपिक ऑफ कैप्रिकॉर्न. हाँ, सपोज ट्रॉपिक ऑफ कैंसर है और ये ट्रॉपिक ऑफ कैप्रिकॉर्न है, तो ये जो सर्कल ये जो मैं ड्रॉ कर रही हूँ, ठीक है, इसको हम बोलते हैं apparent movement of the sun. Apparent movement of the sun. तो हमने ये देखा है कि सन जो है वो ट्रॉपिक ऑफ कैंसर या ट्रॉपिक ऑफ कैप्रिकॉर्न से अगर हम ट्रॉपिक ऑफ कैंसर के ऊपर जाते हैं या ट्रॉपिक ऑफ कैप्रिकॉर्न के नीचे जाते हैं तो सन कभी भी ओवरहेड नहीं होता. ओके, सन ओवरहेड एक बार साल में एटलीस्ट हर लैटिट्यूड के ऊपर होता है, लेकिन वो लैटिट्यूड इट शुड लाई इन बिटवीन ट्रॉपिक ऑफ कैंसर एंड ट्रॉपिक ऑफ कैप्रिकॉर्न. सो दिस इज व्हाट इज रिटन हियर that the midday sun, it's exactly overhead at least once a year on all the latitudes, but only between the Tropic of Cancer and Tropic of Capricorn. And this movement of the sun in between Tropic of Cancer and Tropic of Capricorn is known as apparent movement of the sun. And this area, which is marked here in the blue, is known as the torrid zone. And why? Because it receives the maximum heat. Okay, and then we move on to the next zone, where the midday sun would never shine overhead. Okay, so angle of sun rays is obviously slanting and it goes on decreasing towards the pole, and therefore the areas which are bounded by Tropic of Cancer and the Arctic Circle in the northern hemisphere, so this pink shade over here, and the area between the Antarctic Circle and the Tropic of Capricorn in the southern hemisphere, so this area over here, they are known as the areas of moderate temperatures because they have slanting sun rays, and they are known as the temperate zones. So ऊपर वाले को नॉर्दर्न हेमिस्फेयर वाले को हम बोल देंगे नॉर्थ टेम्परेट जोन, जो नीचे वाला है उसको हम बोल देंगे साउथ टेम्परेट जोन. एंड अगर हम आर्कटिक सर्कल से ऊपर देखें या फिर एंटार्क्टिक सर्कल से नीचे देखें, देन these areas are very cold because the sun does not rise much above the horizon. तो रेज जो हैं वो हमेशा ही स्लैंटिंग रहेंगी और बहुत लेस हीट प्रोवाइड करेंगी, एज वाज द केस विद दिस फिगर. ओके, जब स्लैंटिंग होती हैं तो उनकी एनर्जी कम हो जाती है सन रेज की. ओके, एंड दीज एरियाज यू नो आर्कटिक सर्कल के ऊपर और एंटार्क्टिक सर्कल के नीचे, दे आर वेरी कोल्ड एंड दे आर नोन एज the frigid zones. So this one is the north frigid zone, this is the south frigid zone, sorry, here this is the south frigid zone. So I hope that is clear. 3 zones, heat zones of the earth. Now we have done the latitudes. लेकिन क्या इसमें एक एग्जाम्पल है, अगर सपोज मेरे पास एक लैटिट्यूड है यहाँ पे, okay, let's mark a latitude here. Let's say this is a 60 डिग्री लैटिट्यूड. ओके, मान लेते हैं दिस इज 60 डिग्री नॉर्थ लैटिट्यूड. अब यहाँ पे मेरे पास एक केस हो सकता है कि यहाँ पे मेरे पास सपोज सिटी ए है और यहाँ पे मेरे पास है सिटी बी. अब मैं अगर सिर्फ मेरे पास लैटिट्यूड ही होता, सो आई वुड हैव सेड दैट यू नो सिटी ए एंड सिटी बी दे आर लोकेटेड 60 डिग्री नॉर्थ. लेकिन इन दोनों में दे बोथ हैव ह्यूज डिस्टेंस इन बिटवीन देम. So I cannot locate precisely only with the help of latitude. So therefore I would need another reference point or another reference line, and that reference line here is the longitude. Okay, so to fix the position of a place, it is simply necessary to know something more than the latitude of that place. तो यहाँ पे भी एक example given है, Tonga Islands in the Pacific Ocean and the Mauritius Islands in the Indian Ocean. They are both situated on the same latitude, which is the 20 degree south. But how far east or west these places are from a given line of reference, that will determine the exact or the precise position. So ये जो lines of reference जो हम north से south run कर रही हैं, okay, so you can see the lines here. These are running from north to south. जो latitudes थी, they were running from west to east, right? Longitudes here are running from north to south. Now these latitudes or lines of reference are known as meridians of longitude. Okay, and the distance again between them is measured in degrees. So latitudes में भी degrees में measure कर रहे थे, इसमें भी हम degrees में ही measure करेंगे. And obviously we know degree is further divided into minutes and minutes are further divided into seconds. Now what are the differences between longitudes and latitudes? Latitudes में हमने देखा था कि वो complete circles थे, right? But in the case of longitudes, it's not a complete circle, as you can see it here clearly in the figure. These are the semicircles, right? And वहाँ पे क्या था, parallel latitudes. See, that means I told you what is meant by parallel. Distance between them was always the same. But if you would see here in the figure, this longitude and this longitude, their distance is decreasing towards the poles. Ultimately poles पे जाके वो मिल जा रही हैं. right? So this is the difference. First of all, latitudes they were circles, longitudes are semicircles, ठीक है. latitudes जो हैं उनमें distance same था because they were parallels, right? longitudes में ऐसा नहीं है, distance between them decrease steadily polewards until it becomes zero at the poles where all the meridians meet. So again जैसे हमने इक्वेटर रखी थी 0 डिग्री पे, वैसे ही हम यहाँ पे भी एक लाइन लेंगे, रेफरेंस लाइन, जिसको 0 डिग्री मार्क करेंगे और वहाँ से हम देखेंगे कितना वेस्ट है और कितना ईस्ट है. तो हम बोल सकते हैं मे बी दैट सिटी बी इज 60 डिग्री नॉर्थ एंड इट इज हाउ मच ईस्ट, लेट्स से 10 डिग्री ईस्ट. सो वी विल नो कि 0 डिग्री से 10 डिग्री ईस्ट आगे गया है, तो यहाँ पे होगा बी, और अगर वेस्ट में है तो यहाँ पे होगा ए. ओके, now let's move forward, again continuing with the prime meridian. तो जैसे हमारा इक्वेटर था 0 डिग्री, यहाँ पे जो हमारी 0 डिग्री लाइन है इसको हम बोलते हैं प्राइम मेरिडियन. now this prime meridian, because जिस टाइम पे ये हमने क्रिएट करा था उस टाइम पे यूके was in power or the Britishers were in power, so they decided that this prime meridian would pass through the Greenwich, and which is again in UK, where the British Royal Observatory is located, and this meridian is called the prime meridian. Its value is 0 degree longitude. और यहाँ से 0 डिग्री लॉन्जिट्यूड से हम काउंट करते हैं 180 डिग्री ईस्ट तक और 180 डिग्री वेस्ट तक. Now if you will imagine, because this is a sphere, so ultimately जो इसके ऑपोजिट लाइन होगी, प्राइम मेरिडियन के ऑपोजिट लाइन होगी जो पीछे की तरफ, दैट विल बी 180 डिग्री. ठीक है, अगर हम इस साइड से जाएंगे, ईस्ट से जाएंगे, तो वो 180 डिग्री ईस्ट हो जाएगी. अगर हम वेस्ट से जाएंगे तो वो 180 डिग्री वेस्ट हो जाएगी. दैट मीन्स 180 डिग्री ईस्ट या 180 डिग्री वेस्ट, इट इज़ द सेम लाइन. Okay, so clearly 180 degree east and 180 degree west meridians, they are on the same line, right? Because even if you extrapolate from here, the line which is opposite to 0 would be 180 degrees. If we go from east, it would be 180 degree east. If we go from here west, it would be 180 degree west. Now let's move forward. Again, now it's very clear how can we locate the position of any place. अगर हम सपोज करते हैं, हम जो ग्लोब है या अर्थ है उसको फैला के एक मैप में अगर कन्वर्ट करें, राइट, एंड वी मेक दीज लैटिट्यूड्स, दिस इज द लैटिट्यूड पैरेलल्स एंड 1 2 3 4 5 आर द लॉन्जिट्यूड्स. ओके, तो इस तरीके से ग्रिड बन जाएगा. सो ऑब्वियसली इफ आई वुड से टेल मी द पोजिशन ऑफ सिटी ए, सो इट वुड बी बी डिग्री. लेट अस से ये ए बी सी डी ई जो है वो नॉर्दर्न हेमिस्फेयर में है, सो ऑल ऑफ दीज आर नॉर्थ लैटिट्यूड्स. एंड लेट्स से ये जो लॉन्जिट्यूड्स हैं वो ईस्ट में है प्राइम मेरिडियन के, तो ऑल ऑफ दीज आर ईस्टर्न लॉन्जिट्यूड्स. तो अगर अब मैं पूछूंगी व्हाट इज द लोकेशन ऑफ द सिटी ए, देन क्लियरली इट वुड बी बी डिग्री नॉर्थ एंड विच लॉन्जिट्यूड 1 डिग्री ईस्ट. सो आई कैन क्लियरली से इस पॉइंट पे अब सिटी ए जो है वो लोकेटेड होगी. ओके, सो दैट इज व्हाट इट इज ऑल अबाउट. सो इफ यू सी हियर, इफ वी टॉक अबाउट धुबरी इन असम, ओके, इट इज सिचुएटेड 26 degree north latitude, 90 degree east longitude. Okay, let's move forward. Now you can see here, I told you this is the 0 degree, right, and this is where the British Royal Observatory in Greenwich is located, and this is our prime meridian. अब हमें पता है जो अर्थ है that rotates from west to east. So now try to imagine, right, all the places which will be on the east, they will see the sun first. यहाँ पे sun है, ठीक है, जो हमारी अर्थ है वो रोटेट कर रही है वेस्ट से ईस्ट. सो ऑब्वियसली थोड़ा इमेजिन करके आप देखो, अगर अर्थ घूम रही है तो जो उसके आगे वाला हिस्सा है, यानी कि जो ईस्टर्न हिस्सा है, वो सन को पहले देखेगा, और जो वेस्टर्न हिस्सा है वो सन को बाद में देखेगा, राइट. ईस्ट विल कम फर्स्ट. सो दैट इज वाई you will see here it's written +1 +2 +3 +4 +5 +6. तो ये क्या है? टाइम. ओके, जो हमारा ईस्ट का हिस्सा होगा वो टाइम में आगे होगा, बिकॉज दे विल सी द सन फर्स्ट. Okay, तो हम जितना ज़्यादा ईस्ट में जाते जाएंगे, as we move further in the east, the time will be gained, and as we move in the west, we will lose the time. Okay, so that is the rule. Okay, let me show you what we call it as. So the rule says east gain addition. So whenever you will go towards east, you will add. West lose subtraction. Whenever you go towards west, you subtract. Okay, so be it days or time. So what is basically I'm talking here is the relationship between longitude and time. Okay, हमें पता है local time, it can be generally guessed by the shadow cast by the sun, because noon में when the sun is directly overhead us, the shadow would be the shortest, and sunrise and sunset में because it's slanting, so the shadow would be the longest. Now prime meridian of Greenwich, it has the sun at the highest point in the sky, and all the places along this meridian at that point of time when the sun would be at the highest point there in Greenwich, it will have midday or noon, right? Any place can be guessed like that. If the sun is overhead, it is midday or noon. Now as the earth rotates from westward, that's what we talked about. So those places which are east of Greenwich, they will be ahead of the Greenwich time, obviously, because they have already seen the sun, but the Greenwich is yet to see the sun. So obviously the places east of Greenwich will be ahead of the Greenwich time, and those off to the west will be behind it. And now we know that जो अर्थ की रोटेशन है, ओके, रोटेशन इज बेसिकली अराउंड द एक्सिस ऑफ द अर्थ. तो रोटेशन एक्सिस के अलोंग होती है, रेवोल्यूशन सन के अराउंड जो ऑर्बिट में है वो होती है. तो रोटेशन हमें पता है, एक दिन हमारा कितने घंटे का होता है? 24 घंटे का, राइट? एग्जैक्टली इट इज़ बेसिकली 23 आवर्स एंड 56 मिनट्स. तो बाकी के जो 4 मिनट्स बचते हैं, so they add up 4 minutes of each day, because we use the 24-hour format, but जो अर्थ की रोटेशन है, it takes 23 hours and 56 minutes to be exact. So ये जो 4 minutes बचते हैं दिन में, these are added up, and at the end of the 4th year they are added in the February, and that's called the leap year. We all know that. Okay, now earth rotates, that means earth is a sphere. Okay, we know a complete circle is of 360 degrees, right? So 360 degree the earth covers in 24 hours, right? So you can easily guess how much will the earth cover in 1 degree. So use the unitary method of the maths. It would be 24 divided by 360, and this is in hours, so you can convert it in minutes by multiplying it with 60. Okay, so if you want, you can use the calculator, or I will just do it here. So it is 24 divided by 360 hours, right? But we want it in minutes, and we know 1 hour has 60 minutes, so we will multiply it with 60 to get the, so 6 the 36, then 6 4s are 24. That means 1 degree is covered in 4 minutes. So you can see here 1 degree in 4 minutes, or 15 degrees in an hour. Okay, so that's how the time adds up. So हर एक घंटे के बाद 15 डिग्री longitude आएगी. So if you would have seen this figure over here, it says +1, that means 1 hour ahead of this time. What time? The GMT time. What is GMT? G is Greenwich time. So +1 means that it is 1 hour ahead of the Greenwich Mean Time. +2 means it is 2 hours ahead of the Greenwich time, and so on. So if you would see here, India, it is 5.5 hours ahead of the Greenwich Mean Time. Okay, so if it would be 12 noon in England, it would be 5:30 p.m. in India. Okay, because it is 5.5 hours ahead of the Greenwich Mean Time. And every 1 hour means we have covered a longitude of 15 degrees. So we just proved it here, because in 360 degree, that is the whole earth rotation, takes 24 hours. So 1 degree would be covered in 24 by 360 multiply 60, which is 4 minutes. Okay, and similarly 15 degree would be covered in 1 hour. So I hope that's clear. Let's move forward. And this one is east gain addition, west lose subtraction. That means when you move east, you add the time. When you move west, you subtract the time. Okay, so why do we have a standard time? So I told you, जैसे जैसे हम east में जाएंगे, we will add time, and we know that India also have a certain expanse. So 68 degree east is the point where it's starting, and it ends at 97 degree east, right? So because of this, okay, there might be problems. Why? Because there will be a difference of about 1 hour and 45 minutes in the local times of Dwarka, someone here in Gujarat, and someone here in Dibrugarh, Assam. Okay, so the time difference would be approximately 2 hours from one end of India to the second end of India. So approximately 2 hours or 1 hour 45 minutes to be exact. Okay, like from Gujarat to Assam. So to remove that difficulty, because generally if everyone follows a single time, it's much easier for us to prepare things. For instance, one such example is given, if there is a different timetable or different time for all the trains, okay, if we follow the exact 15 degree thing and we move ahead by 1 hour, then in that case there may be a case that trains can collide, because they will make and it'll be very chaotic basically to make different timetables for trains. So it's better that if we follow a uniform pattern. So that is the reason we have a standard time from Gujarat to Assam, right? So what is this standard time? We have taken the longitude of 82.5 degree east, that is 82 degrees and 30 minutes east. This is treated as our standard meridian, and we follow this meridian to have the time of whole of the country, and this time is known as the Indian Standard Time. So again, as I was telling you, how will you calculate now India, how much hours is ahead? So you have to calculate the difference in the longitudes from the Greenwich. So Greenwich was 0 degrees, and now we have set the standard meridian for India, which is here 82.5 degree east. Okay, so 82.5 degree east. Okay, so you subtract them, 82.5 degree east minus 0 degree, the answer would be again 82.5 degree east, right? Now to calculate the time, again use the same formula. We know that 15 degrees take 1 hour difference, right? So 82.5 degree east will take how much time? So 1 divided by 15 into 82.5 degree or 30 minutes, this much hours it will take. So if you calculate it, it will come out to be 5 hours and 30 minutes. So that is 5.5 hours. Okay, so we are 5.5 hours ahead of the Greenwich Mean Time. Okay, now this is the same example. If we have a match in London at 2 p.m. If we have a match in London at 2 p.m. so how much will that match be in India? Because I told you 82.5 degree east, so it is 5 hours and 30 minutes ahead. So because we are in the east of the Greenwich, okay, India is here, Greenwich is here, so we are going towards east, and I told you east gain addition, so you add 5.5 hours. So if it is noon here, 12 p.m. okay, it was 2 p.m. So the match is starting as 2 p.m. So you add 5.5 hours, it would be 7:30 p.m. in India. Okay, now some countries, they have a great longitudinal extent, and so they have adopted more than one standard time. India does not have as much expense as Russia, right? So there are some countries which would need more number of time zones. So Russia is one example. We will see that, France exceeds even the 11 times. So France is the country with the most or the maximum number of time zones, okay? And Russia basically have 11 standard times for its own mainland. Whereas if you will say that France does not have that much of extent, well, that's because France has some territories which are outside France's mainland as well, right? So that is why. So Earth has been divided into 24 time zones of 1 hour each, and each zone thus covers 15 degree of longitude. So I already told you, let us see here. So these lines that you are seeing, it's a 15 degree difference and 1 hour difference. And similarly, we have divided the whole Earth or the globe into 24 such things. Okay, so because we have 24 hours. Let's move forward now. Okay, so the world is divided by time. So which are the list of countries with the greatest number of the time zones? The first one is France. France has 12 time zones, okay? And why is this unusual span? That is because of France scattered national territories. So I told you France does not have like 12 time zones on its mainland, right? It has 12 time zones, including some areas in French Polynesia which are present in the Pacific Ocean. We'll see later here. They are mainly responsible for such huge time zones. And similarly, the same case with USA. It has again 11 time zones, but again, that is not for the mainland. Over the mainland, USA just has 6 time zones. Whereas if we talk about here Russia, then Russia has 11 time zones all over the mainland of Russia. Okay, now you will see here UTC. UTC basically stands for the coordinated universal time. Coordinated universal time. So this is nothing but similar to the Greenwich Mean Time. The only thing is that this UTC, it is just a successor of GMT. So nowadays, instead of GMT, we write it as UTC. So UTC +1 or +2, because Greenwich Mean Time, it was when Britishers were in power. So now it is known as the Coordinated Universal Time, and they also take into account the slowing of the rotation of the Earth. So this UTC, this also takes into account the slowing of rotation of the Earth. So this is basically the same thing as GMT. Then UK again itself is not that big, but because it has many territories in the oceans, so it has 9 time zones. So if a question is asked, let's say, which of the countries has the maximum time zones over their mainland, then it would be Russia. But which of the countries has the greatest number of time zones irrespective of the mainland, then it would be France. Okay, and then Australia, it has 8 time zones. Let's move forward. Now the international date line. So we talked about the 180 degree east and the 180 degree west line. So I told you to imagine, right, 180 degree east and west line would be the same line. So this line is basically the international date line. So international date line, you can see here, it is located at about 180 degree east or west. Why we are saying at about? Because international date line, it is not a straight longitude. So you can see it here. What is the shape of the international date line? You can remember it. Okay, so some of the islands are included, some of the islands are excluded here. So this one here, the shape, you can see it clearly. This is the international date line. Now it is halfway around the world, and it also lies in the middle of the Pacific Ocean. Okay, and it's halfway around the world from the prime meridian, which is the 0-degree longitude. Now the dateline, again, because it's a meridian, so it runs from the North Pole to the South Pole, and it divides the western and the eastern hemisphere. So in the latitudes, equator was the one which was dividing it, right? Here also it's dividing it into western hemisphere and the eastern hemisphere. But it would be opposite. Why? Because the 0-degree line, if you see the 0-degree line, I will show it to you again. Okay, here the 0-degree line, this way we have the eastern hemisphere and this way we have the western. But if we go in the opposite direction, you will see the opposite. So eastern hemisphere here would be this hemisphere and western hemisphere would be in this direction, because we are on the opposite side of the 0-degree longitude, right? So eastern hemisphere, I told you, east gain addition, so you add, and western hemisphere, west lose subtraction, so you lose a day. So when you cross this international date line, why is it called the international date line? Because you will either lose a day, 24 hours, or gain a day if you cross it. So if you are standing here, you can see here that some examples are given. The Kiribati Islands and the Hawaii Islands, they are on the different sides of the international date line. So here, this is just for reference for some of the islands. You can see here, this is Micronesia, the country of Micronesia. It's called as the Federated States of Micronesia. Then the Kiribati Islands, okay. Then this line, red line, is showing the international date line, so you can know which islands are, okay, western side and which are on the eastern side. Okay, so Kiribati east, okay, Tuvalu east, Samoa Islands, they belong to America, so they are also on the east. Fiji Islands also on the east. Then Cook Islands are in the western hemisphere, and French Polynesia here, again, it belongs to France. So remember, France has a maximum number of the time zones, because see here, one of the countries, French Polynesia, is present here in the Pacific Ocean. It belongs to France. So that would be it for today, guys. I hope you liked the lecture, and I've tried to make it bilingual because some of the students were facing problem. I hope you liked it, and thank you so much for listening. If you liked it, then please like or unlike the video. Do subscribe and do share it with your friends. And thank you. Have a very good rest of your day.